Hello everyone, this is the AWS course made by the 7. And today's lesson is the scale and the load balance your architecture. Okay, let's go to next page. Our target is using the elastic load balance ELB and auto scaling services to load balance and automatically scale your infrastructure. Okay, let's explain that. What is elastic load balancing? It automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve fault tolerance in your application by seamlessly providing the required amount of load balancing capacity which is needed to route application traffic. And what is auto scaling? It helps you to maintain application availability and allow you to scale your Amazon EC2 capacity out or in automatically according to condition you defined. You can use auto scaling to help ensure that you are running your desired number of Amazon EC2 instances. It can also automatically increase the number of Amazon EC2 instances during demand spike to maintain performance and decrease capacity during load to reduce cost. It is well suited to applications that have stable demand patterns or that experience hourly, daily, and weekly variability in usage. Okay, let's explain more. Elastic load balancing feature and the product comparison, which is select the appropriate load balance based on your application needs. If you need flexible application management, we recommend that you use an application load balancer. If extreme performance and static IP is needed for your application, we recommend that you use the network load balancer. And if you have existing application that was built within the EC2 classic network, then you should use a classic load balancer. Okay, today the objective is create Amazon Machine Image AMI from a running instance. Second, create a load balancer. Third, create launch configuration and an auto scaling group. And fourth is automatically scale new instances within a private subnet. And also for create Amazon CloudWatch alarms and monitor performances of your infrastructure. Okay, let us see the environment. Then before and after, we start from AWS Cloud, which with the one VPC, which located at 2 availability zone with public subnet 1.2 and private subnet 1.2. And also we allocate the internet gateway, an NAT gateway, and also have a security group for web server 1 and RDS DB primary, and for second group in different availability zone. And after we build out the thing we want, you can see that we will build a security group to that the web instance and RDS DB in private subnet at the 2 availability zone. And we will also build up application load balancer to deal with the traffic from outside through the internet gateway. And we'll also build up a mechanism, also scaling group. If the traffic is too big to handle, the resources will be added automatically, which is a so-called auto scaling. So we will have 5 tasks. The task 1 is to create AMI for auto scaling, and you will get such kind of picture, Amazon machine images, and we call that AMI. For the task 2, you will create a load balancer, and you create a load balancer that can balance traffic across multiple EC2 instances and availability zone. And we can find several different types of load balancer are displayed in here. application load balancer, network load balancer, gateway load balancer, and also classic load balancer. Okay, you are using an application load balancer that operates at the request level layer 7, routing traffic to target, EC to instance, containers, IP address, and Lambda function, also based on the content of the request. And for the task 3, we will create and launch a configuration and an auto scaling group. And you will create a launch configuration for your auto scaling group. A launch configuration is a template that an auto scaling group is used to launch EC2 instances. When you create a launch configuration, you specify information for the instance, such as the AMI, the instance type, a key pair, security group, and disk. And task 4 is verify that load balancing is working. So you will find it that load balancer here, and we also get the DNS name we can use, and we can use load balancer. Okay, also we will open it from our website to see the current CPU loading and also for load test. The task 5 is test auto scaling. So finally, we can see that we will adjust the CPU the usage, and we can see that if the CPU usage is over here, you will get an alarm, and also will create the other lab instance to support to see that auto scaling. The final is terminate web server. This is the end of the course. So through using the elastic load balancing, ELB, and auto scaling services to load balance and automatically scale your infrastructure. This is the end of our course. And let's start. Okay, let's move into our course. Task 1, create an AMI for auto scaling. And you will create an AMI for existing web server 1. And this will save the contents of the boot disk so that the new instances can be launched with the identical content. Okay, let's go to AWS. And you have to open EC2, or you can run the service here. And when you open EC2 and to click the instance, you can see that we will have 2 web server. The web server 1, which created by the lab, and if the 2 and 2 check path, this means that the service, the instance had to be already opened, and we choose this one to use selection and to create the image. The image we can give the name for the image. Here the name we give is web server AMI, and the image description will be here. Lab AMI for web server. So let's click create image. And you will find here AMI ID had already created. AMI ID already created. So you all can find here. The image here we create already. Okay, let's move in task 2, create a load balancer. And you will create a load balancer that can balance traffic across multiple EC2 instances and availability zones. Okay, let's go back to our instance here, web server 1. And this time we want to create load balancer. So here's the load balancer, create the load balancer here. Select balancer type. What we select is the application load balancer. So create it. So give the name for our load balance. Okay, lab year B and choose a VPC. We want to choose to use our lab VPC and also for secure lab VPC. So the mapping, the lab VPC, what we mapping is we want to map a public subnet 1 and the public subnet 2. Okay, and to select security group here, web security group, but this one is we don't want. Okay, let's move into the listener. Okay, listener here is empty. The first one, we want to create the target group. So the target group here, create target group. The target group name we want to give is for the lab group. Protocol is HTTP, the port is 18. Oh, then next. So register our target group. We register this one. Okay, let's create target group. Okay, you can see that target group had already created. So let's go back to here to see whether we have this one. LGB, we have already created the target type instance IPv4. Then we start to finally we create load balancer. To see load balancer here. Okay, we have already get this one load balancer. Okay, let's move into the task 3. Create a launch configuration and an auto scaling group. And you will create launch configuration for your auto scaling group. A launch configuration is a template that an auto scaling group uses to launch EC2 instance. When you create a launch configuration, you specify information for the instances such as the AMI, the instance type, a key pair, security group, and disk. Okay, let's move in. So the first thing is to create launch configuration. So let's move in to click the launch configuration. Okay, create launch configuration. And to give the name is for our left configure. And for the AMI, okay, choose the AMI. We did it before. This one. Okay, choose the instance type. The T3 we use is the T3. T3 micro. Okay, T3 micro. Then choose it. Okay. To add additional monitoring here. And to select a security, we did it for this one is for our web security group. The key pair here. Use existing key pair, row key, and then create launcher configuration. Okay, we have already created. And then we want to create an auto scaling group. From here, we choose lab configuration and choose auto scaling group. Auto scaling group, then we give the name. This is for our lab. Our lab auto scaling group, we use this name. Okay. I'll choose a VPC, our lab VPC, and choose the zone, or the private zone, private subnet. We said it before. Move to the next page to attach the existing load balance. Our existing load balance group is we did it for LAB group here. And we also want to use the within the CloudWatch additional setting. Click here. For next page, to set up the policy. Desired capacity, minimum capacity, and maximum capacity is 6. Under the scaling policy, okay, let's choose the scaling policy. The policy, our policy name is use the same. It's for our lab, so the name we give is lab scaling policy. Okay, lab scaling policy. So metric type average CPU utilized. The target value, we change it to be 6. What's the meaning of that? This tells auto scaling to maintain an average CPU utilized across all instances at 60%. And auto scaling will automatically add or remove capacity as required to keep the metric at or close to the specified target value. It adjusts to the fluctuation in the metric due to the function load pattern. Okay, the meaning is that. Okay, let's move to next. Okay, add the notification. No need the other notification. And to add a tag. The tag name is key is the name. The value is left instance. Then we go to next. For the summary table, lab configuration and network for the 2 subnet to 4. Load balancer here, target load balancer has JKC2 and group size capacity 226 here. Okay, here is the scaling policy. Required at maintain average CPU utilized at 60. And instantly the 300 seconds to warm up before the including in the metric. Notification no. And the tag we set is for the name and lab instance. Also, Okay, let's create auto scaling group. He created it for us. Okay, you can see here lab scaling group. One scaling policy created, successful group metric collect is enabled. Okay. Okay, let's see here. Lab instance is running. Okay, you can see here, lab instance, two lab instance had to be created, two and two checked and passed. Let's move in task 4, verify that load balancing is working. You will verify that load balancing is working correctly. Okay, let's move back. So in here, we can to see where is our target group. Okay, the target group. Hey. Okay, target group. We can see that we have a lab group here. The group. Okay, you can see here is two lab instance to be created and show the healthy. Okay, let's to check the load balance. Load balancer. Okay, here, load balancer here. Okay, load balancer here. Here one load balance is working here. And we can to open a browser to use a DNS name to check. Okay, you can see here CPU here we have already created. The application should appear in your browser, and this indicates that the load balancer received request and sent it one of the EC2 instance, then passed back to resolve. Okay, let's move into task 5, test auto scaling. You created an auto scaling group with a minimum of 2 instances and a maximum of 6 instances. Currently, 2 instances are running because of the minimum size is 2, and the group is currently not under any load. You will now increase the load because cause auto scaling to add additional instance. Okay, let's move in. Let's move into our EC2. Okay. EC2 before that, let's to see the car watch. Okay, car watch to see the alarm. And here you can see that the target auto scaling group alarm high 70 embedded and here. And CPU utilized is bigger than 60 for 3 data point with the 3 minutes is the policy. Okay. Let's change something for that. Back to EC2 and to use auto scaling group. Auto scaling group left auto scaling group here. Let's change the policy. Automatic scaling. Okay, change policy here. To edit it. Edit for the target value. To change it to 50. And to update. Okay, you can see that update successfully. Every CPU utilized at 50. Okay. Okay, let's back to the CloudWatch. Okay, CloudWatch here has already changed to utilize bigger than 50 for 3 data points within 3 minutes. Okay. Okay, let's go to the plate here. So here is the icon we can use here is load test to push it. Oh, current CPU load is over 73%. 74. So we also can ask him to load. Let's see the alarm. Oh, here in alarm, it's moving now. See the CloudWatch. Oh, over 50. Here 50. So this also means that we will create the other. We will create the other instance. Okay, and now you can see we can see the more than 2 instances be created. Initializing. If I still push here, and you can see the CloudWatch. Well, to show other things bigger than before. Or another one change. 1, 2, 3, 4. Okay, now you can see there are 4 instances to be created. And also for a CloudWatch. And to show here's overloading. It also proves that this function is workable. Okay, task 6. Terminate web server 1. You will terminate web server 1. This instance was used to create the AMI used by your auto scaling group, but it is no longer needed. Okay, let's move back to AWS console, and we can find out the EC2, the web server 1 here, and select this one. Instance state, terminate instance. Okay, let's terminate it. Shut down. Okay. Through using the elastic load balancing (ELB) and auto scaling services to load balance and automatically scale your infrastructure. Is above I talk to you, and thanks for your listening.